whenever we have to measure something in science, whether it be temperature, length, volume, a common question that students will ask is, how many decimal places should I make the measurement to? And here is how. When we measure something in science, we always make sure that we read all the markings, that is all the increments, plus we want to make one estimate. And we do this because we want to be as accurate as possible when we are trying to represent a quantity that we have. For example, let's do this first question here. We have a ruler, we have a piece of paper, it is coming to 11.6. Now, the 11.6, those figures are figures that you are absolutely 100% sure about. The one estimate that we want to read is the one number that falls between two increments or two lines. Okay, so here are our two lines. Estimate where the gray piece of paper there is falling between those two lines, and I would say a fair estimate to make would be 11.65, and then we write down our units. So this is what we mean by when we do a measurement, we always write down all the numbers that we are sure about plus the one estimate. This 5 is our one estimate. We can put the 5 down legitimately because we are fairly certain that it is indeed a 5. So because of that, we can say 11.65, which would be a lot more accurate than if we were to say just 11.6. Let's take a look at the next example. Part B, this question's particular scale, when we read all the increments that we can write 2, that is a number that we're absolutely certain about, and then we make one estimate. In this case, our one estimate is going to be about maybe 5, 2.5, because that arrow falls halfway between 2 and 3. So that is how we measure using that scale. Our plus one estimate is that 5 that we've done. Question C. Fairly certain that it's going to be 2. Fairly certain that's going to be 0.4. Then we're going to make one estimate. That little arrow seems to fall perhaps 0.02 away. We can kind of say that this measurement is 2.42. If you said 2.43, I would also take that on an exam because I think that is a fair judgment. If you were to say 2.5, I probably would take a half mark off because that clearly is not halfway between those two lines. And our last example, dealing with the graduated cylinder. This is a volume. Remember that we always read the meniscus. The meniscus is the very, very bottom of that curve. Okay. This particular graduated cylinder has an inverted scale, 1 on the bottom, 5 on the top. Okay, which is kind of actually it's like on the regular scale, not really inverted. It's just upside down because you're not used to seeing things going upside down. This particular one is going to be 3 point. Now, each of those little lines is going to be 0.2, right? So it's 3.2, 3.4, 3.6. Now it's between 4 and 6. We can probably say that this is 3.5. Makes sense? And it's 3.5 because I'm looking at the meniscus. If you were super confident in your reading skills, you might be able to argue your way through one more decimal place, but I think that would be very challenging to do. Alright. Now, not all measurements you make are certain because sometimes you do have a little uncertainty with that final decimal place that you read. And so sometimes we express our measurements with an uncertainty. Okay? For example, you read a ruler and you think your pencil is 0.51 to 0.53, somewhere between there. Instead of saying 0.51 or 0.53, we can express this number with an uncertainty. We can say that the overall reading is going to be 0.52 plus or minus 0.01 millimeters. And by writing it like this, we very, very concisely say that our reading might be 0.51, 0.52, or 0.53, because it's plus or minus 0.01. So if you were to read a reading that said 7.5 plus or minus 0.1, This reading says that our value might be 7.4, or let me put the units in there, 7.4 milligrams. It might be 7.5 milligrams, or it might be 7.6 milligrams. That's what that symbol refers to. Okay? When we write our uncertainties, it's very important that we make sure that it makes sense. For example, if you were to read a number 7.5 and you reported an uncertainty of 0.01, let's say this is milliliters, we would consider that to be incorrect, because from the 7.5, this 5 is your one estimate. That is the number that you were uncertain about. So it makes no sense that you report a uncertain digit in a place value that is after the 5, because you were not sure of the 5 in the first place. How can you even say that it's 7.56 or 5.1 or 5.2? It makes absolutely no sense. So you always make sure that our uncertainty place value matches the initial reading. So the correct way to write this would be 7.5 plus or minus 0.1 milliliters. So we see that the 5 is placed at the same decimal place as that 1. That makes sense. For the most part, the uncertainty is something that you can decide upon. If you are very, very certain of your measurement, you can report 0.1 or 0.01. If you're not too sure about yourself, you might say 0.2 or 0.02. If you have absolutely no idea of what the uncertainty should be, because you're not sure of your own abilities, the standard procedure is we take the smallest increment and divide it by a tenth. Or we say the uncertainty is usually one-tenth of the smallest increment. So for example, in this scale, what is the uncertainty going to be? If you're very good at measuring, we can look at the smallest increment. The smallest increment happens to be 1. So 1 divided by 10 is 0.1. So our uncertainty for this particular scale is going to be plus or minus 0.1. This should make sense, because if you're reading a value, let's say between here, you could say this is 12.5. So that decimal place will match. So that is how we measure. If you look on the course website, there is a PowerPoint on accuracy and precision. If you go through that, I show you some neat pictures about how costly some of the equipment you use in science are. Basically, the more accurate, the more decimal places that a certain scale can provide you with, the more expensive it is, because it took a lot more effort to calibrate those instruments to a very, very accurate value. Gu out.